should row the boat to minimize the drift. Find the minimum drift. Question is available on screen. We'll determine. So we'll do one thing. We don't know anything. Okay, let him row the boat. VBR. Then river current will push. He will reach here, no? Is that okay? Fine. Sir, this will be our answer. Okay, no, let him row the boat in this direction. Then the river current will push him like this. Then what in the second situation? He will come here, no? Say, I'm asking you to analyze. Don't go for solving the problem. First, you analyze it. What are the conditions are there? Okay, now look at this one. This is VB dash. Tell me in which case it is minimum.
Upstream, sir.
Upstream, sir.
Oh, awesome. I'll show things clearly so that you decide, then get into the problem. So this is VBR. This is VR. So you do have two different situations I'm showing, but different colors. Look at that yellow color one. If the boat follows the yellow color path, it will be available here. Say C dash. If the boat follows the blue color path, you'll be available at C. Looking at this, what do you mean by drift? So look at in both the cases where the drift is less, definitely X dash, no? See, nothing wrong, student drawing diagram. You should analyze the diagrams. This is the method of learning physics. So maximum of you, what's happened, reading question, want to put the one formula and get it. Even if you know concept also, you are supposed to work out, analyze what are the situations are there. Then only you can reach higher level of physics. Otherwise, what happens, see, like, you'll confine yourself to some small thinking. So up the stream or down the stream? Definitely what happens, up the stream is what the boat should be rowed here. Then only the drift can be minimized. If it seems normal to, sir, what will happen if it seems down the stream? Then the drift will be more, no? You put one more VBR here, another color, then you'll be pushed somewhere here till here. So to minimize drift, the boatman what happens, should row the boat up the stream. This is a core idea to minimize drift. The boatman should row boat up the stream. Okay, got this? There's the idea of the problem. Sir, how you can decide from the diagram? Okay, let's come for the question. Let's try to get the answer. So let him BBR, the river current will push. So then this will be the velocity of boat. This is a starting point. So velocity of river. This is the width. So let me take this as theta. Write down the equations now. What is the time taken to cross the river? Time taken to cross the river. What are the formulas we should use? I'll directly take help of this. So first, there's a just there's a analysis. Student must analyze it. This is for solving the problem. Solve from this diagram. Okay, now there's a time taken. W by BBR sine theta. Okay, now what is the expression for drift? VR minus VBR cos theta into T. Shall I write directly? VR minus VBR cos theta. This one. So let me substitute that value of x equal to VR minus VBR cos theta. T is what? W by VBR sine theta. Okay, some information. VBR is equal to VR by root 2. The data is given. The speed of the boat is available for us. The value of that. So VBR is VR by root 2. Okay, solve it now. What to do? Minimum is telling no, not something. He didn't ask to calculate the value. Am I right? He didn't ask to calculate the value. What he has asked is, so how to minimize it? Yes, I'll take help of differentiation. Here VR will get cancelled out. Root 2 will get cancelled. So x equal to root 2 minus cos theta W by sin theta. Check it once.
Yes, sir.
This will be our equation. So what to do here now? I differentiate with respect to theta. The value of theta will determine what's with the minimum drift here. For some specific value of theta, the drift can be minimum. So differentiating this dx by d theta. Root 2 constant it is, minus of w, you keep as it is. So differentiation of sine theta cos theta as it is. Differentiation of sine theta will be you can use u by v method or basic thing. So I'll for your convenient, I'll write it so that will be easy for you. Some of you that quotient rule, product rule, you may find difficult. I'll write it in this form. Root 2 w by sine inverse of theta w cos theta sine inverse theta. Let's differentiate this. Root 2 w. So this will be minus 1. Minus of minus 1 will be minus 2. Derivative of sine theta. Derivative of sine theta will be cos theta minus of w. The bracket term, first cos theta, this will be minus 1. Sine minus 2 theta, this will be cos theta plus the definition of cos theta will be minus sine theta. So this will be negative minus root 2 w. You can use any other alternative method. Write it like this. So this will be minus root 2 w. cos theta by,
Sir, cosecant theta, cot theta.
yeah, anything you can write it. So this will be negative, this will be negative only. So here cos square theta by sin square theta, sin square theta, negative of negative, and this will be minus, this will be positive, no? W by cos square theta, sin square theta, this will be W by, this will be only W. I'll equate for 0, this one dx by dt to get that minima. So W will get eliminated. So we have to get equation for the basic condition. So dx by d theta. Equate for 0, W will get eliminated. Then solve for theta. Anybody value theta?
45, sir.
Theta 45.
45 degrees.
Theta is 45 degrees. That value of theta, substitute here. Substitute here, theta 45 degrees. Then solve for it, the minimum drift. You have to substitute the value of theta in this equation. Root 2 cos 45 W by cos 45. W by root 2. This will be our answer. So to minimize drift, there's a minimum drift. What about the angle, anybody? With the river current, how much that angle should be? 135, no? Not 45 degrees, not our answer.
Sir will get W, sir.
Sir, x minimum is W, sir.
W, X minimum is W. Okay, yeah, fine. I'll make correction. This X minimum is what? W. What should be the angle with respect to river current? I'll give a separate diagram. It'll be easy for you. So this is what VBR, no? And this is the river current. So this is that angle. So this is the value of VBR. So what is alpha? Alpha, this should be our answer. Because anything I should measure with respect to river current. Theta is not with respect to river current. Alpha is with respect to river current. Now you have to be very careful in exam. You'll end up answer theta option there, you'll pick up wrong. Any quantity, the direction of velocity of swimmer with respect to river or velocity of boat with respect to river should be mentioned with respect to river current, not bank. There's a convention is what they follow. Okay, this mathematics may trouble you. So the differentiation minimum, maximum, minimum concept, no, that we are going to apply it here. Okay, no? Okay, we'll take the one more problem. It's a very simple, again, the basic formulas, what you know, that you have to apply it here. Two swimmers P and Q start at same point simultaneously from one bank. Swimmer P swims such a way that he reaches exactly opposite point on the other bank. And swimmer Q swims perpendicular to river current and then walks on the opposite bank to reach the exactly opposite point on the other bank. Both the swimmers take same time. Find the velocity of walking of swimmer Q on the bank. You have to understand that situation here. Say nothing to do. You already know concept. The situation is what you have to understand clearly. Time is less, no? I'll give the diagram. So first we'll take the swimmer P. So what about swimmer P? How he swims? He will swim up the stream or down the stream. There's a river current. How the swimmer should swim? He will swim up the stream, VPR, let me call it. So the river current will push him so that he will reach exactly opposite point on the other bank. Start, there's the end. Is that okay? Now come for the swimmer Q. What about swimmer Q? Swimmer Q swims perpendicular to river current. Directly here only you write it. What is the time taken to move from time taken by swimmer P? Anybody value?
15 seconds, sir.
Yeah, that one. Find the velocity of walking of swimmer. So this TP is equal to what we can write it as W by this particular angle. We don't know this angle. Call this theta. W by VPR cos theta. Let's come for the other swimmer. He will swim normal to river current. The river current will push him so that he will have a drift and he will reach the other bank here. This is start point. But what happened? He should end somewhere here, but he has reached here. So what you do? You'll walk.
Sir?
Hmm.
Sir, could you show the question once, sir? The complete question.
Yeah, wait. Let me finish off this. So you'll walk some distance. So there's a river current. BR, there's a width. I'm bringing the diagram and also the question. Just view it once. I brought all the situation at one place. Huh? Just see things clearly. This is what swimmer P, swimmer Q. Can you directly tell me the formula for this instead of this? I don't know theta, no, all that. Anybody, any formula? Swimmer P, W by VP R square minus VR square. Can you remember this? When it seems, when the shortest path, no? So what is this path? Shortest path. What about swimmer Q? You'll cross the river in swimmer P. Swimmer P crosses the river shortest path. What about swimmer Q?
Shortest time.
Swimmer Q crosses the river finish or no? So tell me like what are the formulas now? The swimmer time taken by the swimmer Q, what will be? He will move from first A to C, then C to B, no? So this is what? To cross the river. Time taken to cross the river. What about this? Time taken to walk on the bank. Time taken to walk on the bank. That is what. And what is given? What is information given? If both the swimmers take same time. What do you mean by that same time? So the TP should be equal to TQ. The value of TP should be equal to TQ. So therefore this will be TP is equal to, or TQ is equal to TP. So this will be, what is TAC? Should be equal to, this will be TP. Now what is TAC? W by VQR, no? What is TCB? TCB is the time taken to cross that river, no? So what it should be equal to? U naught by X. TP is what? W by, but we don't know X, no? Anybody how to bring X? You recollect some ideas what we put. What is from the diagram? What is tan alpha? You can write it. Tan alpha. I think in shortest time, I give some formulas. What is the tan alpha? Tan alpha should be equal to, we can also write VR by VQR, which is equal to X by W, no? Okay, substitute all these values. So X we can replace here, no? And this will be X by U naught, sorry. So we don't know X, X you replace with this value. So it will be, and VQR equal to VPR. W by VQR, X is equal to how much? VR W by VQR U naught W by, so W will get eliminated. So only unknown thing is what? U naught. We know VQR and VPR values. The two, they are equal, 10 meter per second. So I'll write it clearly here. VPR equal to VQR equal to VSR 10 meter per second. Substitute that and solve for U naught. Anybody value U naught?
Sir, we'll get W by VQR as 20 seconds now, sir. But TP is 15 seconds.
No, what will be that? Just substitute here. I don't know what calculations you did.
So one scroll up, sir.
Scroll up.
The TP is not 15, sir.
Sir, 12.
Look at the data all. VPR, VQR is equal to 10 meter per second. VR is 6 meter per second. Anybody value?
24 meter per second, sir.
How much?
24 meter per second, sir.
24 meter.
meter per second.
Yeah, okay, fine. Yeah, that will be our answer. I think the interpretation of that sentences, no, are very important here, because everyone knows this formula. There's nothing, no problem, all this, no. So what is that situation? The swimmer P will cross the river in shortest path. The swimmer Q will cross the river in shortest time. That's all. And that formula you have to substitute here. Okay, tomorrow we'll go for some still problems are there. I'll discuss on Friday. So let me go for some other concepts. Let me touch all the things. Then mixed ideas will bring in the end. That's one. So still more some better questions are there that I'll put on Friday or Saturday. So tomorrow I'll start the minimum separation, relative projectile motion. We'll discuss the concept based on these two topics tomorrow. Okay, all of you. Thank you very much. Okay,
Thank
we'll
you, sir.
meet
Thank you,
tomorrow.
sir.
Thank you, sir.
Yes, sir.
Thank you,
Thank
sir.
you, sir.
Take care.
Yes,
Stay
yes,
safe.
sir.
Thank you, sir.
Bye, sir.
Okay, bye all of you. See you tomorrow. Take care here.